Okay, Algebra 2, this is, we're going to start trigonometry review today. This is just going to be from here to the end of the year. We're just going to be kind of reviewing over different things that I think are really important that I want to make sure you know before going into geometry or whatever math class you're taking next. So right triangle trig, you guys did with Mr. Getzfred while I was on maternity leave. So I'm going to go through all of this again. This packet right here is your notes and homework combined. So the top part of this section is notes, and then your homework is down below here. And it's the same way for the second page. For just today, we're only going to be doing this this side and then this back side, so you'll only be doing this first page here. And not the second page, but keep a hold of this because we'll go over the third and fourth page tomorrow. So right triangle trig is only, this stuff only works for right triangles. So write that at the top of your paper, right triangles, only for right triangles. So it must have a 90-degree angle somewhere in the triangle in order for this process to occur. Mr. Getzfred might have taught you SOHCAHTOA before. SOHCAHTOA stands for sine, cosine, and tangent, and it has to do with the sides that correspond and make up sine, cosine, and tangent. There's a little typo right here. This H should be an A. I don't know why that's an H on there, but TOA should be a TOA instead of TOH. Okay, so over here, when you're looking at like angle A right here, the side that's opposite angle A is the one that's straight across from him. An opposite side is one that is not touching angle A. Like the hypotenuse side is touching A and the adjacent side is touching A. Opposite is the one that's directly across from A that he's not touching. Okay, the hypotenuse side is the one that's directly across from the right angle, and the adjacent side is right next to A. Adjacent means right next to. Okay, now angle A really kind of has two adjacent sides. He's got this bottom side that's right next to him and the hypotenuse side. But because this is already the hypotenuse side, this trumps being the adjacent. So rather than having two adjacent sides, one of them is called the hypotenuse. Okay. Now, down below here, they will go ahead and switch this around. So I'm going to use a different color. If you're talking about, like, let's say angle B up here, if you're flipping this around, so rather than talking about A in this corner, B up here, the side that's opposite angle B is now this one. This one is now the opposite. This guy is the adjacent side, and this guy is the hypotenuse. So it depends on which angle you're talking about to what these guys are labeled. So one of them is adjacent, one of them is opposite, one of them is hypotenuse. The adjacent and opposite switch sides based upon whether you're talking about angle B or angle A in this bottom corner. So you just kind of have to be careful, okay? The opposite and adjacent sides depend on where the angle is, either angle A or angle B, okay? So examples down here, if you have like 22 degrees here, and we're labeling this triangle, X would be the opposite side, and 15 is the hypotenuse side, because he's opposite the right angle, and then this one right here that has no label is the adjacent side, okay? If we label this one over here, part B, 58 degrees, this is the angle that we're talking about. The side opposite is this one, the one that's labeled 18. X is the adjacent side, he's the one right next to, and then this one is the hypotenuse side. So the hypotenuse is one that we don't have any label for, okay? Here in just a minute, we're going to come back to these, A and B, and we're going to actually solve for X in each one of those scenarios, okay? So we'll be back to those. What I'm going to have you do for homework, though, is these bottom three examples, and then a couple on the back, but we'll get to that. These bottom three examples, I'm going to do this first box here with you, or this first little section. Okay. So we have this triangle here, and it is a right triangle, so we can use sine, cosine, and tangent. But they have these labeled. 9 is this length, 12 is this length, and then the hypotenuse is 15, okay? So here we're just doing sine, cosine, and tangent for angle A. So just looking at angle A. Angle A is here. 12 is going to be the side that's opposite angle A. Okay, the hypotenuse is 15. He's going to stay the hypotenuse. And then 9 would be the side that's adjacent to angle A. Okay, so if we're trying to do sine of angle A, if I go back up here to the top, this SOHCAHTOA is going to help me. Sine is opposite over hypotenuse. That's where the OH come in. So, opposite hypotenuse, okay? So I want to, when I'm dealing with sine, do opposite over hypotenuse. The opposite side is 12. The hypotenuse side is 15. So opposite divided by hypotenuse, 12 over 15. Don't try to write that as a decimal. Go ahead and leave that as a fraction, but we want to reduce it as much as we can. So 3 goes into both 12 and 15. It will become 4 over 5. Okay? Now, one little trick that you can do, rather than having to reduce or write these all in and then reduce each one of them, if you look at these numbers that I have to start with and you reduce them over here in this triangle, that'll keep you from having to reduce it 6 different times over here. So I have 9, 12, and 15. 3 will go into all of those numbers. So 3, 4, and 5 is what they will become. If I divide each one of those by 3, then I can just write out 3, 4, and 5 over here, and I don't have to worry about doing the reducing over in this section, okay? So we're going to do cosine next. Cosine is adjacent over hypotenuse. That's where the AH for the K in SOHCAHTOA comes in. So adjacent over hypotenuse, here's A. The adjacent side is 3. And over hypotenuse is 5. So cosine of A is 3 over 5. And just leave it like that. Don't try to put it as a decimal. Okay? The last one is tangent. So tangent is, if we're looking at A still, tangent is opposite over adjacent. That's where the TOA comes in. Opposite adjacent. So the opposite side of A is 4. The adjacent side is 3. So 4 over 3 is tangent. Okay? Now, I'm going to do this one in a different color. I'm going to do orange for this one. Now we're looking at B. So we're going to flip our angle to this side over here. Okay? Now, this side, the side with 12 or the side with 4, was labeled as the opposite side of A, but opposite of B is actually 9. He's directly opposite. So this guy, instead of being adjacent, now becomes opposite. And this guy that was opposite now becomes adjacent. Okay? The hypotenuse is going to stay the hypotenuse. He doesn't flip. But opposite of opposite of B is this side 3, and adjacent of B is this side with 4. Okay? So now I'm going to do sine, cosine, and tangent. Sine is opposite over hypotenuse. Opposite is 3. Hypotenuse is 5. So sine of B is 3 over 5. Okay? Cosine is adjacent over hypotenuse. So if I look at B, the adjacent side is 4. The hypotenuse side is 5. So cosine is 4 over 5. And then tangent is opposite and adjacent. So the opposite side is 3, and the adjacent side is 4. 3 over 4 is tangent. Okay? You're going to do these next two down here below exactly the same way. This one is going to kind of look a little funny because you're dealing with F, E, and D rather than actual numbers. But that's okay. F, E, D, you're just going to put it as a relationship kind of like I did up above. Okay, so that's going to be part of your homework. I'm going to go back up here to these example A and B, and that will show you how to do these 8 problems on the back side here, because these 8 problems will be part of your homework as well. So don't worry about doing anything from this sheet, but this one here where you have these 8 problems on the back side of the front, you want to do those for homework as well. So this is how you're going to do each one of those. Let me focus this in here. Okay. In A and B, when you actually have a triangle and you're solving for x, rather than making the ratios down here, you're solving for x, you're only going to use one of these trig functions, either sine, cosine, or tangent. One of them, not all 3. So we're dealing with 22 as the angle. Opposite of him is x. Hypotenuse is 15. There is nothing actually labeled down here for adjacent, so we're not going to use the adjacent side. We don't need him anymore. Opposite on hypotenuse, the trig function that uses opposite on hypotenuse is opposite hypotenuse, that's sine. So we're only going to use the sine function. We're not going to use cosine and tangent, just sine. All right, now when we use a trig function, we always put the angle inside of that trig function. So sine of 22, I put the angle right inside of the trig function. Okay? Now we're going to do the relationship kind of like we did down here. Sine of that angle is opposite over hypotenuse. So I put x over 15. Opposite over hypotenuse, x over 15. when I want to get x by itself, to get rid of the 15, I multiply by 15, multiply by 15. So x is 15 times sine of 22. 15 times sine of 22. You're going to need a calculator and type it in just like this. 15 sine of 22. Hit enter. And 5.62 is approximately what I get for x. 5.62. Okay? So that means that if I have a triangle looking like this, where this angle is 22 and this side is 15, this side right here will be 5.62. Okay? And part B, same setup using a different trig function. We don't actually have a number here for hypotenuse, so we can scribble him out because we aren't going to use him. But we do have an adjacent and an opposite. Adjacent and opposite, the one that uses that is tangent. So we want to pick that one as my trig function. Tangent of the angle is 58 equals, and opposite over adjacent, opposite is 18, adjacent is x, okay? So tangent of 58 equals 18 over x, okay? Now, when your x is down here in the denominator, to get him, like over here, your x was in the top, so we just multiplied by 15. This one, you could do that, but you're going to have to get the x to the other side. I'm going to show you a trick of how to solve for x, get x by itself. If you just flip these two around, x equals 18 over tangent of 58, that's how you can solve for him. So when your x is in the denominator, you just flip those two positions, and you can solve for x. So I do 18 divided by tangent of 58, close my parentheses just like that, enter, and I get 11.25, just about. 11.25. Again, that means if I have a 58-degree angle and the opposite side is 18, this guy will be 11.25 units long, this guy. Okay? All right, that's it for your homework. Go ahead and do the bottom two sections here and do these 8 on this backside. Okay? We'll start this one tomorrow, and there you go.